Hello students, in this session we shall discuss the factors affecting the stability of the complex ion. So the stability of complex ion depends on these three factors. First one is nature of the central metal ion, the nature of the ligand and the chelate effect. The first factor, the nature of the central metal ion. The greater the charge density on the central metal ion, the greater is the stability of the complex. That is, charge density on the central metal ion, which is equal to charge upon size. So, charge should be large and size of the ion should be very small, so that charge density will be more. So, the metal ion in the complex, if it has got high charge density, then the complex formed by it will be more stable. For example, Fe3 plus ion compared with Fe plus 2 ion. So it has got high charge density. So the complex formed by Fe3 plus ion will be more stable compared to the complex formed by Fe plus 2 ion with the same ligands. So if we see the stability constant of hexacyanoferrate 3 complex ion is about the order of 10 to the power of 31, and that of hexacyanoferrate 2 is only about 10 to the power of 6. So it also indicates that the complex formed by ferric ion is more stable compared to the complex formed by ferrous ion. So as I said earlier, the central metal ion with high charge and small size forms stable complexes. So the size of the central metal ion is also important. So if the size of the central metal ion decreases, it is observed that the stability of the complex increases. If we see the order of stability of complexes formed by bivalent ions, so the order is like this. So in this, copper ion forms more stable complex compared to the remaining ions. So the size of the copper ion is less compared to other ions. So these ions carry same charge, but the size of the metal ion increases from copper to manganese. So thus complexes of copper ion are more stable, and the complexes formed by manganese ion are least stable. So size of the central metal ion is also an important factor. Coming to electronegativity of the central ion. So the greater the electronegativity of the central ion, the greater is the stability of its complexes. We know that ligands forms coordinate bond with the central metal ion. So ligands donate electron pairs to the central metal ion to form coordinate bond. So strongly electron attracting capacity, that is electronegativity, if it is more, then it will form a more stable complexes. Second factor, the nature of the ligand. So in the nature of the ligand, first is basic character. So the more basic is the ligand, greater is the stability of the complexes formed by it. Since more basic ligand means it can donate electron pair easily. So these ions, fluoride, ammonia are strong bases, hence they form more stable complexes compared to other ligands. If we compare ammonia with water molecule as a ligand, ammonia, since it is more basic, is a better ligand than water. And the second in this is size and charge of the ligand. So in general, ligands with high charge and small size forms more stable complexes. So due to small size, fluoride ion forms more stable complexes than that of chloride ion. So if we see the order of halides forming complex with a given metal ion, so fluoride forms more stable complexes compared to chloride, then bromide, then iodide. Also, pi bonding capacity of ligands is also important. The ligands like alkenes, alkynes, cyanide carbonyls, which can form pi bonding with the central metal ion, usually form more stable complexes. Also, steric hindrance has its effect. If a bulky group is present in a ligand, then the repulsion between the donor atom of the ligand and the bulky group, it weakens the metal ligand bonding and makes the complex less stable. For example, complex of nickel ion with 2-methyl 8-hydroxyquinoline is less stable compared with that of complex formed with 8-hydroxyquinoline. So in 8-hydroxyquinoline, additional methyl group is there. So due to steric hindrance, this complex will be less stable compared to the complex formed with only 8-hydroxyquinoline. The third important factor is the chelate effect. So the complexes containing chelate rings or chelates are known to be more stable than those containing monodentate ligands. So complexes formed by chelating ligands like ethylene diamine, EDTA are more stable than those formed by monodentate ligands like H2O or NH3. So chelating ligands adds or accounts for more stability. The cadmium ion forms complexes with methylamine as well as ethylene diamine as the ligands. And the stability constant of the complex with methylamine is found to be 3.1 into 10 to the power of 6. And the stability constant of the complex found with ethylene diamine is found to be 3.2 into 10 to the power of 10. So if we see the stability constant values, we know that higher the value of stability constant, more stable will be the complex. So the complex of cadmium ion formed with the ligand ethylene diamine is more stable, which is of 10,000 times more stable than the other complex. So complexes containing chelate rings are more stable than those containing monodentate ligands. So with this, I will end this session. Thank you.